So all sinusoidal waves will continue forever. What this means is that you can measure them at any point in time and you will get a corresponding value. So if we take temperature, for example, I can measure at any point in the future and I will get, let's say, 15 degrees Celsius. So here we have a simple signal setup. It is 4 uh, times cos 2 pi times t plus 0. So the 4 corresponds to the amplitude of the signal. 2 pi times t is our frequency. So for every signal, it has a sampling interval and a sampling rate. The sampling interval is the time between two samples, or how often a sample is taken. So we have a sampling interval of 0.001 seconds. So every 0.001 second, a sample will be taken. A sampling rate is how many samples are taken in 1 second. So if we do 1 divided by 0.001, we will get 1,000, which is 1,000 hertz, our sampling rate. So this signal will last for 2 seconds. As you can see also, there is no phase shift. So notice how the amplitude is 4 and the signal lasts for 2 seconds on the bottom axis. The red dots correspond to the radians per sample. So in this, we have 20 dots. So it's 20 divided by 2 pi radians per sample. If we were to phase shift our signal, you will see it will go down. So originally it went through the red dots, now it goes down. That's the phase shift. You can have leading or lagging. So the blue would be leading and the red is lagging in this example. We can also express a signal in terms of radians per second. So if we were to run this, here it is in radians per second. So again, it's 4 on the amplitude, the same number of peaks, but it goes just a little over 60 radians per second. We can also express signals in complex numbers. This is done because the complex number stores the magnitude and the phase of a signal. So if we look to the right, we can see we have variable, which is 0.7247 plus 1.864i. We are adding this to a variable 1, and as you can see from the result, 0.7247 and minus 3.687 will give us 3560. In a complex, we have 2, which is the amplitude, and 0.6 is the phase shift. And if we run this, the blue and green are added together to give us the red red signal.